Hi everyone, today I'm going to talk about surface area, which is section 15.5. Alright, in this section we apply double integrals to the problems of computing the area of the surface. Here we compute the area of the surface with the equation z, which is equals to f of x, y, and the graph of the function of two variables, and let s, which is equals to let s be the surface with the equation z if f of x and y, and where f has continuous partial derivative. Alright, for simplicity in deriving the surface area formula, we assume that f of x, y, which is greater than or equal to 0, and the domain D of f is a rectangle. Alright, the area of the surface with the equation z, which is equals to f x y, which is x and y are elements of domain where f of x and f of y are continuous. Continuous is surface area double integral d f of x, x and y, the whole square, plus f of y, x and y, the whole square, plus 1, the radical dA. So we're going to use this formula to solve the surface area on this section. And also that if we use the alternative notation for partial derivative, we can rewrite this equation as surface area double integral d, which is under root of 1 plus partial derivative z with respect to x. So we're going to square it. The same for y. dA. So we notice here the similarity between the surface area formula in the above equation and the arc length formula, which is L, which is equals to 1 plus dy over dx, the whole square dx. Alright, using these points, we're gonna solve a problem now. Alright, find the area of the surface. So the part of the surface, which is 2y plus 4z minus x squared is equals to 5, and that lies above the triangle, vertices 0 0 2 0 and 2 4. All right, so the first thing that I'm going to is like to find f of x and f of y, the partial derivative. To do that, we're gonna isolate we're gonna isolate z. So for z, which is equals to 5 minus x squared, no, plus x squared minus 2y. So z, which is equals to f of xy, 5 over 4 plus x squared over 4 minus y over 2. Alright, from here we can find f of x, xy, which is equals to 2x over 4. Basically this is equals to x over 2. So the same thing for y, f of y xy, which is equals to minus 1 over 2. Alright, now I find that my f of x and partial derivative for with respect to x and y. The next thing that I'm going to do is to find the boundaries on the x and y direction. So simply what I'm going to do is I'm gonna plot those points that I have on the graph, on the xy graph. So if this is x and this is y, let's say 1 2, if this is 2 and 0, my second point, and if I can plot this one to 1 2 3 4, alright, this point is 2 and 4, and it's obvious that this point is 0 0. Alright, so now I know that my lower limit for on the x direction is 0 and the upper is 2. So I can write boundaries for the x, which is 0 less than or equals to x less than or equals to 2. And for y, what I'm going to do is to find the equation for this line. And since I know the lower boundaries, I'm gonna use the function as my upper boundary. So if I take 0 0 and 2 and 4, I can find the slope from these 2 points, y2 minus y1 over x2 minus x1. M is equal to 4 minus 0 over 2 minus 0. So my slope is 2. So taking 0 0 as a point, now I can find the function of this line, y minus y1, which is equals to slope x minus x1. So y minus 0 to x minus 0, y is equals to 2x. Now this is the function for this line. So I can use that one as upper boundary. So my lower is 0 less than or equals to y less than or equals to 2x. Alright, now I know my boundaries and I know my f of x and partial derivative with respect to x and y. Now I can use the formula to solve the surface area. Alright, the formula that I'm going to use is w integral d 1 plus f of x square plus f of y the whole square dA. Now my dA is dy times dx. So I know my partial derivative with respect to x, and I know my partial derivative with respect to y, and I know my dA, which is equal to dy dx. All right, let's substitute everything what we have and solve the surface area. Okay, so my boundaries for x is 0 and 2, and for y is 0 and 2x. 1 plus my partial derivative with respect to x is x over 2 the whole square, plus my y is minus half the whole square dy dx. All right, so now before we integrate the whole equation, it is better to simplify using the algebra skill. So we're gonna simplify the best we could to find the simple equation. So my surface area 0 to x 1 plus x squared over 4 plus 1 over 4 dy dx. Surface area 0 to 4 plus x squared plus 1 over 4 dy dx. This is equals to half times 0 to x, which is equals to x squared plus 5 dy dx. Alright, now what I'm going to do is like I'm gonna integrate any variable that I have y with respect to dy. So here, since I don't have any variable y variable in this function, I will consider this one as a constant. So I'm just gonna write it again. X squared plus 5 y. So my lower is 0 and my upper boundary is 2x dx. Surface area is equals to 1 over 2 0 2. This is equals to x squared plus 5 2x minus 0 dx, and this is equals to 1 over 2 0 to 2 x squared plus 5 2x dx. Alright, my next step is to integrate the rest of the integration. I'm going to use a new paper. Let me rewrite the equation again. 0 to 2 All right, so to solve this integral, I'm gonna use a technique called usub. So I'm gonna substitute x squared plus 5 by u. All right, du is equals to 2x dx. And since I'm substituting x squared this function by u, those boundaries are only work for the x variable, so I'm gonna change the boundaries using this function that I have. So if x is equals to 0, u of 0 is equals to 5. Okay, no problem with that. And if I use 2 for x, 2 squared plus 5, so u of 2 is equals to 4 plus 5, so u of 2 is equals to 9. Alright, so we're gonna replace every x variable that we have in this integral by u. So surface area is equals to 1 over 2. So instead of 0, I'm going to use 5. And instead of like 2, I'm going to use 9. And u have, and instead of 2x dx, I can use du. Now, it is simple to integrate this one by adding 1. So surface area is equals to 1 over 2 u 1 plus 1 over 2 over 1 plus 1 over 2. My boundaries are 5 to 9. So surface area is equals to 1 over 2 u 3 over 2 over 3 over 2. 5 to 9. Alright, let me rearrange the equation that I have so it will be visible to see. 1 over 3 u 3 over 2 5 to 9. This will give us 1 over 3. Instead of u, we can substitute 9. 9 is which is equals to 3 squared. 3 over 2 minus 5 3 over 2. So I can cancel 2 by 2. So surface area is equals to 1 over 3 3 the power of 3 minus this is which is equals to 25 1 over 2 surface area which is equals to this is 27 minus and square root of 25 is 5 root of 5. Alright, so this is the surface area. Alright, I basically touched the basic concepts of the surface area and how to solve the problem. Thanks for watching.